As we all know, first order linear differential equations take the form of c1 of x times y prime plus c2 of x times y equals g of x. Like separable equations, solving first order equations is a mechanical process, and it can be solved by following the 5 steps that I'll be showing to you guys. Step 1. Make sure the coefficient of y prime is 1 in this form. If it's not, you have to divide the entire equation by c1 of x to obtain the following form. So let's say, example, you have, let's put it back, c1 of x times y prime plus c2 of x times y equals g of x. If this right here is not equal to 1, you will have to divide the whole equation to c1 in order for you to get an equation similar to the form above. So for example, if we need to solve dy over dx minus y over x equals x to the power of n, where n is not equals to 0. As you can see here, step 1 is done because the coefficient here is 1. So we can go to step 2. Step 2, you will have to compute the integrating factor. The integrating factor can be found by doing e to the power of the integral of p of x dx. Therefore, in this example, the integrating factor, or mu, e to the power of the integral of minus 1 over x dx. In this case, p of x is considered to be the minus 1 over x. And now you have to solve the integral in this case. And the integral of minus 1 over x times dx. To solve this, we know that the integral of 1 over x dx is always equals to ln of x. In this case, it's going to be negative because there's a negative sign in front. Therefore, this becomes minus ln of x. And therefore, we can say that mu, or the integrating factor, is equals to e minus ln of x. However, this is not done because we can still simplify e to the power of minus ln of x. We all know that e to the ln of a constant will always be equals to a constant. If we add a negative sign, this becomes 1 over a. And always remember that. So therefore, in this case, the answer will be 1 over x. Now we are not done because there's still 3 more steps left. Step 3 is to multiply the entire equation by mu. So by doing the left-hand side of the equation first, this will become the derivative of mu y equals mu times f of x. So let's go back to our example. So we want to get this kind of model. Therefore, in this example, it will become d over dx of 1 over x times y equals 1 over x times x to the power of n. In this case, f of x is equals to x of n. If we simplify this equation, it will become d over dx of y over x equals x n minus 1. We know that x to the power of a over x to the power of b is equals to x to the power of a minus b. You always have to remember this, and this is what we applied to find x to the power of n minus 1. Step 4, we will need to integrate both sides and solve for y. Therefore, it needs to look like mu times y equals the integral of mu times f of x times dx, and we have to solve it for y after that, which looks like this in general. Let's go back to our example to do the step 4. Since we're doing the integral of both sides, this will cancel out, which becomes y over x, and we're looking for the integral of x to the power of n minus 1, and you always have to add dx plus c. Always add this right away. And now let's solve the integral of x to the power of n minus 1. Now let's focus on how to solve the integral of x to the power of n minus 1 dx. We can start by doing a u substitution. So n minus 1 will be replaced by u. Therefore, we will find the integral of x to the power of u times dx. Now this is much easier to solve, and this will be x to the power of u plus 1 over u plus 1 plus c. Always remember to add the constant. Now you can put back the original form where u becomes n minus 1 plus 1 and n minus 1 plus 1 plus c. And as you can see here, minus 1 and plus 1 cancels out. Same thing in the denominator. Therefore, this becomes x to the power of n over n plus c. Therefore, the answer here gives x to the power of n over n plus c. Therefore, y over x is equals to x to the power of n over n plus c. And now we're going to solve for y. Therefore, the x will be multiplied on both sides, and this cancels out. Therefore, we only have y left on the left side, and on the other side, to the power of n over n times x gives us x n plus 1 over n. Therefore, the final answer is x to the power of n plus 1 over n plus c times x. So now you have learned how to solve a first-order differential equation by doing an integrating factor.